In this question, there's a horizontal disk which has a hole through its center. So the hole is right at the center, as you can see over here. Right, there's a string passes through that hole. It starts from mass m, the bigger mass m. The small mass m is rotating on the disk, so it is sort of thing like that in a circular motion of radius r. Okay, determine the speed of m such that the big mass stands still. The first question arises that why will the big mass stand still? To answer that, we are going to draw the free body diagram of big mass m. Of course, the gravitational force or the weight is going to act down, so capital Mg will act down. There's only one thing which can prevent it from falling is the tension in the spring. Okay, this tension in the spring is going to hold it and will not fall when this tension is sufficiently large, capital Mg, right? So this is a condition for M to not fall. Okay, that's our condition for the M to not fall. But in the question they're saying what is the speed of M, small mass M, which is rotating. Now let's look at the forces acting on small mass M. Small mass M is also going to be only one force, which is the tension, right? Which will provide sufficient centripetal acceleration to rotate like that, right? So in this case, this tension force is our centripetal force. Okay, so tension force going to act as a centripetal force, providing sufficient centripetal acceleration for small mass m to rotate in a circle. And now we can say that this centripetal force has to be FCP will be equal to small mass m into v square by r, where r is the radius of the circle. Okay, so and this is FCP is the our tension force. This T is going to be mv square by r. We are going to substitute it in the question number 1 and see what happens. So my T is equal to capital Mg, but T is also equal to small m v square by r. Both of them are equal. Capital mass Mg going to be m into v square by r. So r will go on that side. Now we get capital M gr is going to be small m v square. We'll take the m down. We get m by m gr, and my v is going to be this much underscore mgr divided by m, and that is what the question is asking. So found that at what speed it should rotate so that the bigger mass is stand still, and that will be our speed under root mgr divided by capital. Okay, so there's always better to think in that way to start with the condition that why certain things are happening in a particular situation. In this situation, they are saying why capital M will not go down sufficiently. By drawing the free body diagram, we can see that the tension is the only force, and then how much tension could be answered by seeing that the small mass m is actually rotating in a circle, so that's equal to the centripetal force, right, which is mv square by r, and from there we can make the equality of this t and t to arrive at our answer. So that's the way we think about answering this question.